Mm, Gathering. Good
Okay.
afternoon, ladies and gentlemen. Welcome once again. Welcome to Sonal Knowledge series that we are running since couple of months. And today, 28th February, last day of the month, and at 4 p.m. we are talking about thermography inspection as per IS 16168. Very interesting topic. While we, chatting with Peter and Shyam, who's the managing director, we're trying to understand various application other than electrical. So, look like thermography has so many applications. Let's understand, how this and warm welcome once again on this today's topic. So rapidly evolving industrial landscape, electrical safety is more than ever. Thermography inspection plays pivotal role in detecting potential faults, preventing failures, and ensuring reliability in electrical systems. So today's session is aimed to throw some light on importance of thermal imaging, industry best practices, compliance with IS 16168. So we are so grateful that to have our international speaker, Peter Pawlik, who's the technical director of Sonel Instruments, as our esteemed speaker today. His expertise in thermography and electrical safety will provide us with valuable insight and practical knowledge. Also, moderating today is our good friend Shyam Ravindran, who's the managing director of Sonel Instruments, big with wealth of experience, and he's been traveling length and breadth of the country. Man who never sleep, never rest is our Sham. So I encourage you to stay tuned and be on the topic and ensure that you post your questions only on this today's topic. Do not deviate from this topic. And as we progress on this today's session, we do not put your question in the chat box. There is a Q&A box below, and you can just type there, and we will take up the question answer. We are trying to do this whole event in next 1 hour, extend maybe another 20 minutes more. And today's our moderator is Shyam, as I said, with 15 years of international Indian experience, electrical testing and measuring in India and Europe. He is a qualified master in electrical power engineering from WT Poland and certified professional from thermographer. He is an expert on thermography. He has published various articles and papers, including CIRED in Sweden. So today's star speaker is our Peter Pawlik, who's now become quite familiar face in India. Okay, his pronunciation also more like India now because of his involvement in Indian audience and talking and understanding our English. So he is more of our Indian friend now. So he's a graduate of faculty of electronics in the Washa University Technology. He has over 10 years experience in Sonu Group. Peter actively participated in the implementation of new product. He collaborated on several meter design, such as MPI 530 IT, multifunctional meter, and PAT 805806 IT, portable appliance tester, and adjusting our product to the US market. Peter is specialist who's willing to share his knowledge and experience to our Indian audience. He conducts lot many online trainings thanks to webinar participants to have opportunity to obtain professional knowledge without leaving. Thanks to the training conducted by Peter and also Sonal for continuously engaging with audience in educating on various subjects and conducting on measurements. Sonal meter today, one of the largest selling product, and also I believe in thermography, they have overtaken the world leader, and in India they sell the maximum. So I leave the opening remarks to Shyam. I know you have a lot to talk to the audience today. Over to you. I'm going to unshare and over to you, Shyam.
Thank you so much, Mr. Dominic, for the kind introduction. Before I begin, a big shout out to your team from Blue and Gray. Without your team's effort, this webinar would have not been possible in attracting or sharing the messages continuously in all the social media platforms, inviting the customers personally. So, a big shout out to your team. They have done a tremendous effort in organizing not only this webinar, all the previous webinars. So, the previous webinars, as we were mentioning, the topics of electrical vehicle as well as the PV charging stations both attracted a good audience, and we are now doing a lot of, I will say, research activities now with the market. Yesterday we did some important presentations for thermal not thermal for the solar PV installation with some central government organizations after our webinar. So our topics are being monitored, our topics are being well addressed by the customers. After that, our team takes up the topic, and yeah, it's going on the right way. We are educating the audience what is written on the standard. That is very important. So thank you so much for this kind introduction and the stage. And
Thank you, Shyam.
before I begin, a quick intro to our friend, Mr. Piotr Pawlik, who joins from Poland, a good friend. Now, as Mr. Dominic mentioned, he's a famous face in India now, at least from our industry. He has given a lot of presentations. He has traveled with me length and breadth across the country in India. Uh, in all modality of traveling, he has carried out. So he's more Indian than many of us. He has witnessed in almost all different type of power installations across India. So today's topic, whatever we are going to discuss, Piotr can also not only share from the paper, but he can also definitely share his experience, what he has seen in India, and he's also traveling across the globe for training and presentation. So he can definitely add some value in that. So welcome, Piotr, for the webinar. And topic for the day. This is about the thermal imaging inspection as per the Indian standard for electrical installation. So it's a very important topic. Before I begin into the thermal images, I do have an experience of at least 15 years. My first sale of a thermal imaging camera happened before 15 years to a thermal power plant in India. That was my first sale in my career on this product. That was so. I have seen the journey of thermal images hands-on for the past 15 years. How it travel, what are the new advantages that it is happening. Not only from electrical installations, I've seen various different kinds of applications on thermal images. But for today's session, we'll stick to the electrical installations. However, what are the other applications which we have seen? Just to give you a quick shout out, will be, for example, we have seen educational institutions in India. I will not want to name any names here, but a leading research institutions have called in for identifying what is the melting point of some specific metal which is used in space application where it has a change on the diaphragm of that particular material. I've seen this in the tire plants and identifying when exactly the cooling part, I mean the cooling point of their process is happening. I've seen this. We have also seen this in during COVID applications. This was used in every airports. So this has a wide range of applications. But we wanted to address the topic today from the basis of the Indian standard, which is very important for us to look into it because we are noticing that we are very familiar about the camera. We are very familiar to identify most of us. I mean, most of the people who are even attending in the webinar are using the cameras regularly. Uh, but I have seen some of the quick questions from the customers regularly. For example, why do we bring this standard and the topic of a technical discussions here is there are cameras for as low as the price and there are cameras for as high as the price. So what is the right tool for you to use? How do you define what is the right cameras for you to use? That is very important. These are some of the basics to start with, because even today we have noticed that customers sometimes do find it difficult to identify which model of which resolution of the cameras they are supposed to use. And another important part is, before we begin, usually we do not bring this statement, but for this session, we want to bring this statement. Thermal imagers cannot be the all-in-one tool for our electrical maintenance. That is exactly why we wanted to run this webinar. We have an Indian standard which recommends the guideline practice of this particular measurements. But will this measurement give you all in one box solution for our activity? Definitely no. We need to look out for all the other recommendations given from the Indian regulations, and we need to follow it. So does thermal images deserves to be in the place of electrical maintenance for safety? Definitely yes. Does thermal imager is the only testing tool for an electrical safety? Definitely not. So this is the quick statement which we wanted to make. Now, as I mentioned, I do have my certifications on thermography. I'm a level 2 certified thermographer. So for me, thermal images is not about just identifying the hotspots. I have been using this camera. I've seen the technology behind the camera. So the cameras which I use for one set of application for one set of customers, definitely I do not recommend it for all the other customers. So there are a lot of physics behind it. How do you identify a hotspot? How do you take a decisions? Because now we are also reaching to a point, how do I take a meaningful decisions from the hotspot? So there is a detailed depth discussions which we can take after a thermal imager is captured from the camera. With this quick remarks, again I wanted to emphasize the parameter that this is a very important tool of measurements. I will say it is overdone, or we can even put out a word that it is overlooked. So we wanted to emphasize some of the parameters that is mentioned in the Indian standards, but I'll just make another quick remark. This is a very brief standard. Any thermographer who is using this, or any certified thermographer will agree to this point, that this doesn't have any detailed technical recommendations in this standard document. But when you take a decision on your thermal images, you are supposed to have your own certifications. There are level 1, level 2, level 3 certifications in the practice across the globe for thermal images. We highly encourage you to take such certifications. It will definitely improve your knowledge on this when you take your decisions. So with this, I will want to thank once again the hosts, Mr. Dominic, and I want to welcome the speaker for the day, Mr. Piotr Pawlik. Piotr Pawlik, thank you once again for joining us, and please take the dice. Yeah, welcome, Piotr.
Okay. Well, hello everybody, and welcome. Well, again, thank you very much for Mr. Dominic for arranging this. And now I will show you my presentation, and we are going to talk about thermal imaging in electrical applications. So yeah, I think you can see my screen right now. So let's start. Well, first, we're talking thermal imaging cameras. They have many applications. We can use them in electricity to check switchgear, transformers, different fuses and breakers, insulation, connectors, and so on. We can use them in mechanical industry to check some mechanical elements. Usually, if there's some fault, then those elements are overheating. We can perform energy audits of buildings, inspect heating, ventilation, and air conditioning. We can use the cameras to check quality of some products. Also, we can use them for security, like to spot for some robbers or some people that are illegally crossing some borders. We can use them in medicine to detect hotspots. Usually when there is some inflammatory state on the body, then it creates a hotspot. So that's how we can use it. Also for fever detection, like Shyam said earlier, during COVID, I think we all have seen cameras at different places. Also, we can use it for rescue, veterinary, firefighting, and much, much more. But yeah, today we are going to focus just for the electrical applications, and I'm going to tell you about the standard IS 16168. This standard gives the guidelines on the application of infrared thermography technique for a qualitative and quantitative inspection of electrical installations, and it outlines recommended procedures for the inspection and lists the responsibilities of the end user and the thermographer. So that's the scope of the standard. In case you are interested, let's remember that you can download the standard free of charge from the website of BIS, the Bureau of Indian Standards. Okay, so now first let's look at the definition of the infrared thermography, and this is the science of acquiring and analyzing thermal information from non-contact thermal imaging devices. So we have here, we are checking the temperature in a non-contact way, so we don't use any probe, we don't need to touch our object. And we acquire different information about the distribution of temperature, about the values of temperature, so we can analyze them. And well, in the scope on the norm, there were some words about qualitative inspection and quantitative inspection. So what are the differences between these two? So this is my cup. I have some coffee inside my cup. And qualitative inspection is when we are not actually interested in the values of the temperature, but more about the temperature distribution over the object. So here, for example, on my coffee cup, I can see what is the level of coffee inside, but I don't really care what is the temperature of the coffee. Now, on the other hand, quantitative inspection is where we care about actual values of the temperature. So here example is what is the temperature of my coffee. I don't care how much there is in my cup, but what is the actual value. So we have those two types of studies. Typically, qualitative we can use to check level of different objects in the containers, to check, maybe compare when we have a three-phase installation, compare the connectors, breakers, or well, some other parts of each phase with each other, but we just don't care about the value of temperature. And the quantitative, well, to give some ideas, for example, when we are checking the breaker and we have some manufacturer specs, and we just want to check if the temperature of the breaker is within manufacturer's specs. So these are the two types of studies. Okay, now let's start with part 7 of the standard. And it tells us to choose the right equipment. And of course, we need to choose the infrared camera correctly. We need to use appropriate accessories and filters. Because, well, the good equipment, it is essential to get to perform successful studies. And at Sonel, we have a choice of different thermal imaging cameras. When we are looking at the cameras, of course, what comes to our mind is the range of temperatures. So we have here the simplest model from -20 up to 400 degrees Celsius. Then higher models, they have wider ranges. And optionally, we can also use high temperature filter to extend the temperature even up to 2000 degrees Celsius. So, well, let's say typically in electrical appliances, in electrical application, we don't need such high temperature. Here, for example, in a steel mill, maybe in a glass mill, we can find some really high temperatures. Okay, so these are our cameras, and once I will lead you through the standard, I'm going also to show you what equipment we can offer at Sonel. Okay, now the next point here in of part 7 of the standard says about the wavelength of the camera. And typically we are using short wavelength, so 2 to 6 micrometers, or long wavelengths 7 to 14 micrometers. They can both be used for inspection of electrical installations. And well, when you check Sonel thermal imaging cameras, we are all of our cameras are within this wavelength. There might be some differences in case you need, for example, thermal imaging camera for gas inspection. But for electrical, all of the cameras, they have they are checking this length of the waves. So here now to give us some ideas, because we have different waves here in our surrounding environment. Let's say the shortest ones, that would be the gamma rays, and then the wavelength extends up to FM or AM radio waves. Now with our eyes, we can see only a small scope, this tiny bit over here. Well, in the middle, this is the visible light, and we see from about 400 nanometers to well, above 700 nanometers. Now above that range, we have the infrared part. So that is over here, and this is from 0.8 micrometer up to 1000 micrometers. So these are the infrared waves. Okay, the next part are the lenses. And here the standard says that the typically infrared camera use 20 or 25 degrees lenses, which are fitted within the instrument. But sometimes we may want to use different lenses, like photo lenses or maybe wide angle lenses. So to give you the idea, well, here I have visual pictures, but well, just with our eyes we can get a better idea. So we have a 22, nearly 23 degrees lens here in the bottom left-hand corner. And all of these pictures that were taken from the same spot with different types of lenses. Now let's see, it all depends on the application. Here with this, well, 23 degrees lenses, well, we can see some areas, some people are playing football there. But in case we would like to focus and see the details, like a particular person or the ball, then we're going to need to use a telelens. So that's in the bottom right-hand corner. Obviously, as we are looking further, the angle gets more narrow that we see. But thanks to this, we can see better the details which are in the distance. Now, on the other hand, let's say we want to look at some electrical panel which is very close to us. We are in some, let's say, hallway, and we cannot go further back. Well, then the good idea would be to use a wide-angle lens, or so-called a fisheye, so then we can see more. And here we have example in top left-hand corner. So right now we see all the area, all the field, people are there, some trees around it, and so on. But well, this gives you the idea that how much we can see with a wide-angle lens, but we cannot spot the details, at least not in that picture. And then with telelenses, we have a more narrow field of view, but we can see better the details. And as it comes to Sonel cameras, well, you can see that typically we have this 25 degrees field of view, just like in the standard. And in options, we have telelenses, we have wide-angle lenses, and filter for high temperatures is also a sort of lens which we put on top of our regular lenses. Okay, the next thing is the calibration, and the infrared camera needs to be calibrated, and the calibration should be traceable to international Indian standard. Well, so the best way to do this is to calibrate your cameras at some laboratory which has the NABL accreditation. So this is the National Accreditation Board for Testing and Calibration Laboratories. Then it's easy. This is the accreditation authority for the laboratories in India, and if the laboratory is accredited, then you will get traceable calibration of your instrument. Now at Sonel, well, here in Poland, we also have accreditation, also the national body, but different nations, so the name is PCA. All of the laboratories are accredited to the same standards. So there's ISO 17025. And once you buy a new camera, you can also get a calibration certificate with accreditation from us, from Sonel. So you can see here there's a type of the camera, there's a serial number. Normally, I mean, this is just example certificate, so there are no numbers, but normally there is a serial number, so this makes it traceable. And we see the conditions in which the camera was calibrated, as well as we can see the results. Okay, the next point here of the standard, this is the safety-related documentation. So what do we need? Well, we need a customized emissivity table, preferably created by the thermographer, which is dealing with particular survey. Also, black tape to determine unknown surface emissivity. Now I'm going to leave emissivity for later because in point 10 of the standard, all the phenomena are discussed. Now further on, we need the battery for our cameras, and we need some spare storage, well, somewhere to store our pictures. And of course, also we need all the necessary personal protective equipment required for the task. Now, there may be some differences depending if we are just checking like some electrical distribution board in apartment building, or if we are checking a transformer station, then we have certain particular requirements for protective equipment from electrical point of view, not the thermal imaging. And that's why we need this protective equipment appropriate for our work. Okay, now let's look at the procedure of taking a picture. So first, we need to check the parameters, such as load of our installation. So let's remember, we need to make thermal imaging studies typically on live energized installations. Now, why is that? If the installation is de-energized, there's no load, then there will be no overheating effect, no heating effect. So we would not be able to spot any abnormalities. Okay, so that's the load. Then the ambient temperature, which is the surrounding temperature or reflected temperature, relative humidity, wind speed, and once we know this, we can start inspecting our installation. Again, I will get to ambient temperature, humidity, and so on a little bit later in point 10 of the standard. Okay, then we need to ensure that we have all the necessary authorization. Like, for example, we are authorized to access some transformer station, some distribution substation. So we need to have the authorizations. Then we need to make sure that we have the right power supply to our thermal imaging camera. And here the standard gives some options from the mains or from the batteries. But at Sonel, our cameras, they are powered with the batteries. Here, the lower models, they have a built-in battery, but it lasts for a long time, up to 16 hours, so that's pretty good. And in higher models, we have replaceable lithium batteries. Now you may want to check the accessories, because for some models we have two pieces of batteries in standard. For some models we have just one. But anyway, when you have two pieces of batteries, then you can work on one battery. Once you run out, you have the second one. Okay, Then the next point, we need to make all the necessary interconnections and ensure it. So we need just to make sure that all our electrical equipments are connected, all the installations are connected. Then we need to insert the formatted flash card into the disk drive or into our camera. Now, as it comes to our cameras, they all have the memory on the SD card, and the higher models, they also have a built-in memory. And as it comes to the connection to later download the data to a computer or to some other type of hard drive, well, we can use the USB cable in all of the cameras. We can remove the SD card and place it in a computer. The higher models also have the HDMI adapter or HDMI connection. We have LAN, we have Wi-Fi, and some of the cameras also have the Bluetooth. So there are different ways of connecting the camera to download the pictures or to download the movies. Okay, next point of the standard, we need to switch on thermal imaging equipment and then perform a calibration test to ensure all the measurements are within manufacturer's specification, the manufacturers of the camera. Now here our cameras, they calibrate automatically. So once you turn on the camera, it calibrates itself. And then every short period of time, the camera is going to close. You're going to hear like a click for slightly longer than a second. I want to say between 1 and 2 seconds, and then opens up the lenses again. So this is the moment when the camera performs the self-calibration. So basically these points happen automatically when you are using Sonel cameras. Okay, then we need to ensure that the equipment that we want to examine is under adequate load. So again, if there is no load, there will be no current flows. Nothing is going to heat or overheat in our electrical installations. So that's why we want to make sure that our installation is live, is energized, and the loads are connected. So basically, this is just a normal way our installation would operate. Okay, the next point is that we need to focus the camera on the object that we are interested in. And this object should take at least 80% of the region of our picture. So let's look at this. Here you have example of unfocused blurry picture and nice sharp focused one. Well, what does it mean for us? Well, first of all, on a blurry picture, we cannot see what is actually there on the picture because it's blurry, right? So that's better to have the sharp image. And second of all, let's remember how the camera is working. It is measuring the infrared radiation that is reaching the camera's detector. And then the amount of this infrared radiation is calculated into the temperature, by using the algorithms inside the camera. So if the picture is blurry, then the camera doesn't really know how much radiation it's getting, and that's why also the readings of temperature will be untrue. So that's why we need a sharp picture. And how can we get the focus? Well, the lower end cameras of Sonel, they have the fixed focal. So then we just need to come closer or further from the object that we want to check. Then camera 256F has automatic focus. So F is for focus, while all the higher models, so 500 series and 600 series, they have both automatic and manual focus. Okay, further on about pointing the camera. So we need to point it at a certain angle towards our object. If we do it at the straight angle, 90 degrees, this point, then we will just see our own reflection. We will see the reflection of the thermal imaging technician. Yeah? So we don't want to do that. On the other hand, when the angle is too wide, we will not check the temperature of the object, but see mostly the reflections coming from other side. So these are some unwanted situation. The best angle to point our camera is between 40 and 85 degrees in either direction. So that's between those blue lines here. Now further on, the camera has certain markers, like some certain points. But let's remember that the point is 3 pixels by 3 pixels. So altogether it covers an area of 9 pixels. And we want to make sure when we are checking the temperature of a point that this 9 pixel area covers the area of same temperature. If it's on the border of two different objects, then you're gonna get average value from those 9 pixels. And it may not be true because here on this pink side, the temperature is higher, on the black side it is lower. So here this 6.8, probably this is not true because like half of the marker is on a area of a different temperature than the other half of the marker. So that's why this is the correct situation of the pointer. Okay, then the next standard says that the picture should cover at least 80%, well, the object that we want to inspect should cover at least 80% of the picture. Now here I have some visual pictures to give you just the idea. Imagine that we want to inspect some transmission line, and for that reason we will look at the insulators on this line. And if we would get the idea to stand back and take a picture of the, several towers of the transmission line, then if this picture was in infrared, you would have no idea what's going on because there will be just some small dots of warmer temperature, but we would not get the good idea of what's the temperature distribution on our object. So that's why, for this reason, we need to take picture or maybe even a few pictures of each insulator individually and check the distribution of temperature on that insulator. Well, still, again, you can see on this picture, you can, even with the visual picture here, you can hardly see the insulators as the power line gets further and further. So that's why we need to take each insulator individually. Okay, then the next point of the standard, we need to enter to our camera parameters such as emissivity, ambient temperature, and relative humidity. So we can do this before we take the picture. We can adjust this also during our study, or in case we make an error, our cameras allow it to change emissivity, ambient temperature, or humidity after the picture is taken. So later, either on the camera or in the software. However, there are 3 parameters which cannot be changed. So we need to focus on them before we take the picture. And first one, this is the exposure. So whatever I see on the picture, this is everything that I see on the picture. If something is outside the picture, I'm not going to see this. So exposure, this is, well, pretty straightforward. Second one is focus. So if we take a blurry picture, it will be blurry. We cannot change it later in the software. And the temperature range of the camera. Now I'm talking here about the temperature range of entire camera. Like, for example, some of our cameras, they have ranges from -20 to 600 degrees, but there are actually 2 ranges, -20 to 150 and 150 to 600 degrees. So we need to select this range appropriately. And later, once we are taking the picture, the camera automatically narrows down the range of the picture, but not the range of the camera. So let's remember, exposure, focus, and temperature range of the camera. We need to make sure that those parameters are selected correctly before taking a picture. Okay, next point is to take the picture and save it to, well, here flash drive, hard drive, but in fact on the camera we have the SD card or internal memory. And there are some features that can help us take the good picture and determine everything correctly. So first of the feature, these are the palettes. So we can see here different colors. Usually it all depends on the approach of the user of the camera, which palette they are going to select, and maybe on some conditions. Well, there are some ideas where a particular type of palette is useful. Like, for example, here we have a gradient palette. And this is very useful when we want to detect a level of something. So, for example, I don't know, let's say level of oil in a container, then it's better to use the gradient type of palette. Or sometimes when we are just interested in some hotter or colder spots, we can use also the gray palettes. Here, for example, in the top right-hand corner, you can see that the hotter parts are in red, while the rest of the picture is in gray. Okay, and as it comes to number of palettes in our cameras, depending here on the model, Sinclair models, they have just 6 palettes. Well, the highest model has 12 palettes, but the most recent development, we put here 16 different color palettes. Then the next thing which is important about the camera and the size of the picture. So this is the infrared resolution. And here you have some examples from 90 by 120 pixels up to the big one, 640 by 480 pixels. But let's remember that the number of pixels does not only work for the size of our image, but also we have temperature values for each and every pixel. So for example, let's take something here in the middle, 256 pixels by 192. That gives us actually nearly 50,000 points with temperature reading. Yeah, so that's a lot of points. And this is also the special feature of thermal imaging cameras, that when we are talking about resolution and detector size, this is the detector that detects the infrared radiation and calculates everything into temperature. Okay, here's another example of different resolution where I extended all the other pictures to be the size of this 640 by 480. So you can see that the smaller pictures, they are just getting blurry once we stretch them. Okay, and as it comes to our cameras, this is the biggest difference, actually, the resolution, because you see that we have plenty of different models, but, well, let's just say that we have 500 series, which have the same user features, same operational, same type you operate this. In 600 models, also you operate them in the same way, they have the same features. But the difference between each model, this is the thermal resolution and the size of the detector. Okay, next thing which helps us to take the picture, this is the image mode. Well, obviously, infrared cameras, they detect infrared waves, and therefore we have the infrared image. But also, cameras can have a visual image. And later, when we have visual and infrared, we can mix them both to make it easier for us to detect some spots. Well, I'll just say the things that we can see on thermal image, infrared image, is not necessarily corresponding with what we see with our eyes in the visual wavelengths. So sometimes we can get confused. And to avoid this, the cameras have both infrared, visual image, and then the mixture of two. This is the MIF function in Sonel cameras. So over the infrared image, we can see contours of the real objects. And the PIP, this is picture in picture. When on top of visual image, we have overlaid the infrared image. Okay, and as it comes to our cameras, all of the cameras have both infrared, visual, and the picture-in-picture mode. Only the simplest model does not have the MIF mode with the contours. All the rest models, they also have this feature. And further on, when we are talking about saving a picture, earlier I was talking about the lenses, but in case we don't have the appropriate lens, we can use a panorama feature of our cameras. So there, sometimes like with a regular digital camera or the one we can find in our cell phones, we can take a few pictures and then the software automatically combines them into one bigger one. Same we can do with our infrared thermal imaging cameras. So there's a panorama mode where we can take up to 9 pictures, and the software is going to combine them into one picture. Also, there's a super resolution mode where the regular picture is going to be extended in the software to make it look bigger. However, let's remember that the number of points with real values of temperature depends on the size of the detector. So once we enlarge it, there will be some pixels for which the temperature values are going to be averaged. But still, it is let's say some good idea to extend it, so later we can put this on a printed report and then just the picture is bigger. All right, and here with our cameras, when we are taking a picture, we can freeze it. Photo, that means it is saved. And that's with all of the models. And then with the higher models, so series 500 and 600 cameras, they also have a panorama option, and they have a super resolution option, which is basically twice the value of the regular resolution. So when we use the super resolution function, we extend the size of the picture twice. Okay, and how the pictures are saved? For all of the cameras, pictures are saved as extended JPEG. So this is JPEG, which also includes information about temperature. We can add the voice note, we can add the text note, we can well put some other additions, and this is the JPEG in which the picture is saved. Now, when we take a picture with the camera, it actually takes 2 pictures simultaneously. One, the infrared one, and one is the visual one. So then once we want to open them in the designated software, we need to make sure that we have both files in the same place. This way, we can combine the visual and the infrared, and also with the designated software, we can get information about temperature. Now we can also open a JPEG with actually any software for doing anything with the photos. However, you are not going to get data about the temperature. Only the designated software, so Sonel Thermal Analyze, will give you the data about the temperature. Also, higher models of the camera, so series 500 and 600, can record videos. And those videos are saved as MP4 or IRGD files. Okay, so that was, well, that's not part of the standard, just say take a picture, and then I gave you a little bit elaborated information here on what we can do, how we can save it, what are different modes. But now let's come back to the standard. So now we need to analyze thermal imaging using appropriate software. And here with Sonel cameras, especially the higher models, we have some analysis tools on the camera. So all of the cameras, they have some basic analysis tools where we can find the hotspot, where we can see the minimum, maximum, or average value. We can just narrow down to get some part, just some area from the picture, and to check what are the temperature values there. Now for extended analysis, so like we can put the isotherms and cut off all the values below or all the values above the isotherm, or just see what's in between. We can analyze areas of different shapes. We can put many points, analyze lines, and so on. So pretty extensive analysis tool, which is in the camera, and that's in the higher models, so series 500 and 600. Also, for these cameras, we can create a report on the camera itself. So we can generate a PDF on the camera, and there's no need later to connect to the computer and do some additional work. Well, let's just say, as long as it's a regular, simple infrared study. Once we want to do some advanced analysis, it's still just more convenient to use a computer. Okay, so that's what we get on cameras. Additionally, we have also PC software, which is called Sonel Thermoanalyze. Right now is version 3. Or we have application for smartphones, which is called Sonel KT Mobile. Okay, then the next point of the standard says to record the results, analyze, and report as per format approved. And later, further on, I'm going to show you that format. You can also find this in the standard. And of course, we need to document all the exceptions during our examination. Now, in case we see some anomalies, some unusual patterns, the standard recommends to re-examine these abnormal patterns just to make sure that we are really dealing with some anomaly rather than, let's say, some error made by the thermal imaging technician, or caused by some unusual reflection or some other, just say, environmental problems. So if we find anomaly, we want to re-examine that. Okay, now what is not in the standard, but when we are talking about the equipment, what additional function we can find in the cameras? Well, there's the GPS, there's a compass, so we can make sure if we are pointing our camera to north, south, east, or west. There could be a flashlight, so when we are somewhere, I don't know, in a dark basement where there's electrical panel, we can put a flashlight and we can see with our eyes what's going on. We have a laser pointer, so this way we can see at where we are pointing our camera, or we can have a laser rangefinder, which will give us the distance from the object that we are checking. And here you can see comparison of our cameras and what additional functions they have. Well, all of them have a laser pointer, the LED flashlight, and in higher models, so series 500 and 600, we can also find a rangefinder, GPS, and compass. Other useful feature, that's like here we have one of our top models where we have a rotating display, we have tilted lenses, we have a touch screen, we have a viewfinder. So you can imagine when we want to reach some place which is not easy to reach, we can then bend the lenses or rotate the display in order to put our camera in the right direction. Okay, so what are the features here of different models? Well, the SIMT gear cameras, we operate using the buttons on the face of the camera. Higher models, series 500 and 600, they have a touch screen. When we are talking about the viewfinder, so only here the series 600, they have a viewfinder. Now, when we can use it, when we are in a really bright sunlight, it is just hard to see the screen of the camera. Well, you can get the idea, even when we are looking at the screens of our cell phones, mobile phones, sometimes in a bright sunlight, we can hardly see the screen. So same is with the cameras. Then we will just look through the viewfinder, and this way we will avoid all the distractions coming from the sunlight. And the rotating display, this is in the model 600 as well. Okay, so now let's get to point 10 of the IS 16168, and let's discuss the factors influencing the temperature measurement. So first of all, the emissivity, which is a very important parameter that allows us to measure the absolute temperature of the component that we are checking. And the emissivity is particular for particular types of surfaces that we want to measure. So that's why we have some reference tables. Now, when we want to talk about the emissivity, we need to remember that our objects has the possibility to emit the heat. This is the emissivity. They can reflect, so that will be the ambient temperature or the reflected temperature. And some can't conduct the heat radiation. So that's the permeability. Now, oh, too far. Okay, so now conducting heat, it happens really rarely, so we can just skip this part. And let's see what's going on with all the other factors that are influencing our picture. So here we have the camera and the total radiation which is reaching the camera detector. That is the emitted radiation from our object, the gray thing, and the reflected radiation. So the ambient temperature. Now, where this reflected radiation comes from? Well, from other different objects that we can have. For example, in the room, we have some light bulbs. Well, we can have like some heaters or air conditioning, which can heat or cool our objects. So, well, yeah, sometimes even the heat of a human body can distort the reading of the temperature of the object that we are reading. So we have different sources of reflected radiation. And once they are pointed at the object, some of this radiation will get absorbed and some will get reflected and reach the detector of our camera. So how to get this value, so both reflected and emitted radiation that is reaching our camera correctly? So we would get the temperature reading just from the emitted radiation. Well, for this point, we need to set the emissivity. So basically speaking, the emissivity is the amount of this infrared light waves which is reaching our detectors. For example, let's say we're going to set the emissivity at 0.8. So that means that 80% of the radiation reaching the camera's detector come from measured object, and the remaining 20% comes from the environment. So to better understand this influence of the accuracy measurement, let's say the total radiation that reaches our camera can be calculated into 100 degrees. And now we are setting the emissivity of our object at 0.8. That means that 80% of this radiation comes from the object. The other 20 degrees will be, 20% will be just deducted by the camera. And therefore, it is going to show the temperature of our object at 80 degrees. Now, in case we set the camera incorrectly with the value of 0.2 for the emissivity, then for the same object and same condition, the camera will present the temperature of our object as 20 degrees. So this can cause a very big measurement inaccuracy. And example on the picture, you can see here, this is our demo board. The temperature of the demo board is 50 degrees. And it has some black material here in the middle, just to avoid any reflections. And then the emissivity here can be set to 1. Yeah. But we have different materials on the sides. There are metals, they are polished and matte. And like you can see here on thermal imaging picture, well, you can imagine that those are very thin parts of metal. So once they get heated by the heater to 50 degrees, they are all in 50 degrees temperature. But the amount of the radiation coming from those different materials, it differs. So although the real actual temperature here is 50 degrees of all of these materials. They vary from 21.7 up to 47.7 degrees. So it all depends how we set the emissivity. And now in the manual and on the higher models of the cameras, we can find a table with emissivity values for different types of substances. Like we have asphalt, ceramic, aluminum, human skin, we have wood, paper, iron, and so on. But what in case we have, for example, a concrete which is painted? Then we would not know because, well, concrete has 0.9, but maybe the paint is influencing it. And for that reason, this is actually why the standard recommends to have insulating tape with you. Here you have an example. So I'm checking here some sort of a pipe. Now the pipe is made of metal, so rather low emissivity. So metals are working like a mirror for the infrared radiation, and therefore the temperature reading will be higher up. So what can we do? I can put the insulation tape on the pipe, like here, or on my object. I can set the emissivity on the camera to 0.95 and measure the temperature on this piece of tape. Like here you can see 47 degrees Celsius. And later, if my object is much bigger, I can adjust the emissivity in my camera. So for the other material, it will be showing this 47 degrees, the actual value. And then I can check the remaining parts of my object. So this is one of the ways how to check emissivity when we are unsure about it and when we cannot find this in the table. And basically speaking, this is, in my opinion, the most influential parameter as it comes to thermal imaging. Because if we set it incorrectly, it will create a big differences in the readings. Okay, the other temperature, the other parameter, this is the ambient temperature. So basically the temperature which is reflected by the objects that we want to check. And here, ambient temperature for us, this is the summary heat radiation reflected by the measured object. And in case of a flat surface, we can assume that the angle of reflection is equal to the angle of incidence. There may be different sources of radiation reflected by our measured objects, like, for example, walls, cabinets, lighting, and heating, ventilation, other objects. So on this example, we don't need to know the temperature of this light bulb, like we can see over here, but we want to know how much radiation reaches our measured object from the direction of the light bulb. And how we can do that? Well, here the emissivity of the object will determine how much radiation is absorbed and how much is reflected. Yeah. But therefore, all radiation coming from the direction of the light bulb over here, it should be measured. So before such measurement, we need to set on our camera all the correction parameters to 0. So distance to 0, emissivity to 1. And we need to check the whole radiation coming from the direction of this light bulb here towards our measured object. And there are 3 different ways to do this. Well, the first one, this is the immediate measurement, like on the picture on the left. Then in the middle, we can see a measurement with the use of a mirror. And here we are talking about infrared mirror, which could be a material of a very low emissivity, like, for example, aluminum foil. So yeah, this is just working like a mirror. It is only reflected radiation from the light bulb, and this is the way we can measure it. And in case we have some spreaded sources of the radiation which is reflected, then we can use a shutter. So that would be some object with high emissivity. before we perform our measurement. Now, the value of temperature that we measure with this way, it is presented as the ambient temperature or the reflected temperature. And once we enter its value in the camera, later we can normally perform the regular measurement in a correct way. And here you can see some example of reflection. So that was in a steel mill. Here is the furnace where they melt the steel. So you can imagine the temperature is really high. It was, I think, above 1,600 degrees Celsius. And here you can see that in front of this furnace, the temperature of the floor is 140 degrees Celsius. Well, so here, well, we can easily say everybody can imagine that this is just the reflection. This is not some sort of abnormality. And how we can also spot the reflections? They have sharp edges, yeah, like you can see over here. Because usually sharp edge is either when some object is finishing and another one is starting. But when we have one surface, one type of object, it is usually the same temperature, or if the temperature changes, it will do this gradually. And the reflections, we can see that they have sharp edges. Okay, then the next parameter, this is the relative humidity. So of course it influences the temperature, particularly when the distance between the camera and our object is greater than 500 meters. So for this reason, we need to check the humidity and enter the correction factor of the relative humidity into our camera. Further on, loading. So here we want to make sure that our electrical objects that we are checking, they are live, energized, and under some load. So that is going to create a current flow. And as the current is flowing, then some objects are heating, overheating, and so on. Also, we need to evaluate if the load is even on all of the three phases, so then we can compare them with each other. Then we have the wind. Well, as you can imagine, we have a cooling factor on our objects. And in the standard, you can find the table with the correction factor depending on the wind speed. Then we have the rain. Again, it's going to influence the temperature as it is causing a cooling effect on the component that we want to measure. So typically during rain, thermographical results will not be accurate and will not be satisfactory. So we try to avoid rain as much as we can. Then the solar reflection. So remember, especially when we are making some measurements during daytime outside, the part on which the sunlight is falling is going to get heated, not from heating coming from the object, but just heated from the sun. So we need to use appropriate filters, viewing angles, or just maybe wait until sun sets and then perform our measurements in the dark. Also, let's remember not to point our camera directly at the sun, because camera has a sensitive detectors, and there's just so much infrared waves infrared energy coming from the sun that is going to damage our camera, and then you will have to send it to the repairs to have it adjusted and calibrated. Okay, further on magnetic fields. So here, especially when we are talking about some places with higher values of voltages where electromagnetic fields appears. Well, they also are sort of the waves which can distort our infrared waves that we want to detect. Okay, then let's go to point 11. Okay, I'm trying to speed up a little bit so we can finish in time. So how we can interpret the thermal images. And here the standard says that for the interpretation, the thermographer shall know the following information. So first of all, we need to have the knowledge about the component that we are inspecting. And we need to have the knowledge of the load and the current flow in the path of this inspected component. So basically, here when we are making thermographical studies in electricity, in electrical applications, then it's good that the thermographer is also an electrician who understands what we are checking, what the hotspots mean, because we can have, let's say, a good thermal imaging technician who can find a hotspot, but doesn't really know how it influences the electrical system. So that's why we want to have some electrical knowledge in this situation. Also, we need to well, look at the environmental condition of the inspection, so we know how to correctly set our camera. And finally, we should have the knowledge of the component surface and its conditions. So this way we can enter the right value of emissivity into our camera and get the right value of the reading. Okay, so we have found now some anomalies, how we can classify the faults. So first we need to, well, when we find some faulty connection, we need to take some corrective measures. And there are some criteria that we need to evaluate. So first, there is the load. If it is present during the measurement, if it's even or fluctuating, what would be the expected loading situation in the future? And also we need to check, is the overheating measured directly on the component that we want to check, or is it conducted through some parts, like for example, we see a cover of a component, but something inside is causing the heat. Okay, and now how severe are the problems, the anomalies that we find? Well, there's a table in the standard which says that if the difference from what we are expecting, what happens in normal conditions, is below 10 degrees, then we just monitor it. There's nothing special, nothing unusual. If the difference between expected temperature and the value that we received is between 10 and 25 degrees, we should investigate this problem during next schedule maintenance activity. If it's between 25 and 50, we need to repair the problem at the earliest possible opportunity. And if the difference in temperature is above 50 degrees, then it must be repaired immediately, as it is an emergency situation. So yeah, so of course, these are some recommendations. Now, what is the expected value of temperature? Well, let's look, for example, in normal conditions, what happens. We can compare three phases between each other if they have even load. We can check manufacturer specs of different breakers and connectors, just to make sure that the temperatures that we measure are within the right range. Okay, now how frequently we should inspect the objects? Well, there are several factors that we need to take into account. The age and condition of the system, the loading, the degree of redundancy of the plant and equipment, the seasonal or production loading, and of course the cost of the electrical failures to the businesses. So we see, for example, if the system is older, if it has high loads, then it is more endangered to overheating and to breaking. Okay, then the next, when we perform some infrared studies, then we can identify different anomalies. And then we need to identify the problem and determine what is the how severe is the problem, so we can make the right decision if we should repair it immediately, or if it just we can just monitor it if it's not such an important failure. So we just need to evaluate how severe is the problem that we have detected. Okay, and finally the report. So we can see in the standard this table, which is example of the report. Of course, we need to identify our building, enter images numbers. We need infrared image and the visual image, so the photo. Details about the location, details about the environmental conditions, and analysis. So this is in case we find any anomalies. We can put the points, we can put the values of temperatures, and we can enter some further comments to describe what we have found. And of course, we can determine what is the cause of the fault, and we can make some recommendations. Well, and finally, the authorized personnel should sign it. Okay, so we are getting closer to the end. That is it as it comes to the standard. I just want to highlight a couple of advantages of using Sonel thermal imaging cameras. Well, the firmware on which the cameras are based is Android. So you can imagine that it is pretty easy to operate them. Like we know how to operate our mobile phones, similar way we can operate the cameras. So the user interface is just simple. Now we have a possibility to create a report on the camera, which just speeds up our work because we can do this directly on the spot. We can perform a picture analysis in the camera. So again, when we have some complicated situation, it's just more convenient to use a PC. But if we have some typical situations, we can quickly make some analysis, determine the cause of a problem on our camera. Now to any picture, we can add some additional information like text note, voice note, or a sketch. We have here, well, different lenses. Here depends on the cameras. So we can have tilted lenses and rotary display. Resolution here depends on each individual module, but, well, I think easily we can find the models that can just fulfill our expectations. We have a GPS, digital compass, and a lot of different interfaces later to connect the cameras to a computer or to some kind of a screen. Okay, and some applications. Here, these are some images taken at the switchyard with a good clarity. And we need to consider, of course, the infrared resolution and to get the right camera. So here you can see, yeah, some places at the switchyard. Another situation which I would like to highlight are the telelenses. So here, somewhere just outside Bhubaneswar, there have been checked some insulators here, and they were pretty high. So for that application, we had to use telelenses. I mean, when I was telling you earlier that the insulators should cover like 80% of the picture, and I showed you some description, well, here we have a problem because the object is just so far away that even when we are using telelenses, this is what we see. But how we can overcome this? In the software or on higher models of the camera, we can just mark the area and then perform the analysis of this particular area. So this is the way to overcome this problem. Okay, so I can see we are slowly getting to the end. Well, thank you very much for for attending my presentation. And now, if you have any further questions, well, you are welcome to ask me those questions.
Yeah, thank you, Peter. There are good round of questions that's coming in, and those who would like to put up their question, use the Q&A box, and it is at the bottom of your email. You can find Q&A, and the question has to be very specific to today's topic. So I'll just try and pick up these questions, both Shyam and wherever Shyam can pitch in, he can probably join in answering. So Suresh C is asking suitable camera for transformer testing where HDN LT connection. To use Sham?
Yeah, to this particular question, sir, though with taking with all the references of what Piotr Pawlik has told, for the sake of audience on a general level, I'll give this answer. You can choose a camera of 320 by 240 resolution with a degree of approximately 25 degrees. That should be a right range of the cameras to for this application. 320 240 as a pixel resolution with a field of view about 25 degrees should be suitable for this application. Piotr, any opinion from your side?
Well, yeah, I agree. I cannot say anything more. Yeah, I agree.
Yeah.
Suresh has one more question. What is the minimum distance to be maintained between camera and the switchgear installation?
Piotr, would you like to answer or
Okay,
can
so
I?
the infrared cameras, they work the same way like any photographic cameras. So we can define the minimum distance and the maximum is infinity. So as it comes to minimum distance to get the right focus, because, well, this is basically what is keeping us away from the objects from the point of taking the pictures. That would be the minimum focus. And here the cameras they have defined, depending on the model, it's between a half meter and 1 meter. This is the minimum focus. The maximum is infinity, but let's be realistic. We need our object to be large enough so we can recognize it on our picture. Yeah. And as it comes to safety of the inspection, so for example, we don't want to get too close because there might be arc flash that can kill us. Well, here we need to, well, just check the safety recommendation for the electrical equipment that we want to check.
Thank you.
Added to this,
Yeah,
all the questions, I mean, most of the questions, as I noticed, Mr. Dominic, were connected to the resolution of the camera and the distance. There is a calculation. I'll quickly share my screen if you can all see the screen. Yeah, can you see the
Yeah,
screen?
yeah, yeah.
Yeah, so
yeah.
very quickly, because usually the distance is distance and the size of the objects is what usually customers ask for taking a decisions. So for a field of view, you can, for example, I mentioned a minute before, you can use a 25-degree camera, but okay, you can use approximately whatever is the field of view. Then you need to convert the field of view to 1 radian. So that is actually 3.14 divided by 180. That's a thumb rule formula, yeah. So from field of view, you need to convert it into radians. So that gives you a number of, let's say, 0.429. Now, field of view to radians have to be further converted into IFOV. This is the calculation we are all supposed to do when we choose the distance or the size of the objects. Once when you have this number, you need to know what is the size of your object. So when you have these two numbers, just divide it and you can have a calculation what should be the approximate distance for you to take the decision. And this distance is the distance between the camera to the object. And if I have noticed one more question related to overhead line applications. So when you have a overhead line applications, as we know, we have a Pythagoras theorem, you need to know what is it ground distance, and you also should know what is the vertical distance. By analyzing this both, you will be in a position to take an appropriate decision, because most of the questions in Q&A were connected to this one simple calculation formula. So we'll keep this as a base and we'll move on to the questions in a deeper way. Piotr, would you agree to this calculation?
Yeah.
Okay, so I'll stop the screen. We'll take the questions furthermore. So field of view shall be converted to radians. Then you convert it into IFOV with the object size.
Yeah. There are people have raised their hand. If you want to ask a question, I have unmuted. you can unmute your mic and ask either Shyam or Peter. Those who raised your hands, please unmute and you can ask. If you're not asking, I'm going to remove the permission to talk. So Gangadhar, Rajan, Balu, and Bagaran. So if you want to speak to them, you have a chance to speak to the speakers. Okay, let's move on. Um, Quick we can because there are 20 questions are there. What is the IEC corresponding to IS 16168, Sham?
So though there are no direct correspondence, even in our last webinar, we discussed about solar testings. So there is a reference of 62446-3. You will be able to identify thermography for outdoor applications. And for power transformer applications, the IEC number is 676. Yeah.
Okay. Vijay Kumaran is asking how often calibration is required.
Recommended for the manufacturer is 1 year, sir. So we recommend 1 year.
Yep.
Though it
So-
can vary from supplier to supplier, we recommend 1 year.
Okay. So Tawfiq is asking how I have a query. That is it mandatory to set a reflected temperature in thermal camera? And will it reflect any impact on temperature in thermal image? Is it not set because not all devices having this setting? Hope you can read the question, Peter.
Yeah, I think all of the thermal imaging cameras have a setting of reflected temperature. Sometimes it's called ambient temperature. But I would say this is one of the basic features. So not only Sonel cameras, but also of other manufacturers should have this feature. Now, on the other hand, is it mandatory? Again, it depends on your environment. If you have any influential sources of reflection, then yes, yeah. Then we should set this.
And that is over. The repeat question on this. Shivam, what is the minimum and maximum range for thermography camera? Minimum and maximum. So that also is answered. I will skip that.
Well, this depends pretty much on the model of the camera. I know you can check the specs of our website, so sonel.in. But I would say the highest model, it goes from minus 40 degrees Celsius up to 800 degrees Celsius, and with optional high temperature filter, even up to 2000 degrees Celsius. So that's, let's say, the highest model with the biggest range.
Okay, Shyam, you are there. We're not able
I'm here, but unfortunately my video is not starting. But I'm here, sir. Can you hear me?
Yeah.
Yes.
I can hear you. So Silambarasan is asking for metro rail application, measuring or height will be more than 30 meters. Which type of thermal image camera is suitable? So would you like to take this question offline and talk to him directly, or you would like to address?
I can take this offline, but the answer related to the distance, what I've showed a couple of minutes before in a calculation remains the same. But now when we talk about overhead line, again, the same distance shall be converted into the horizontal distance and the vertical distance. So you get whatever is the angle. Related to the type of the camera, with what Piotr has shown, we would wanted to extend this offer to the camera which has a possibility of a tiltable lens from the construction. So from the analysis part, it will remain the same. I will also, I believe Mr. Silambarasan has my email address. I will also drop in my email address. We can take out the questions later very deeply as well. No problem.
People look at chat box. Shyam's mail ID is given, so people wants to connect.
Yeah.
So feel free. Okay, Raju, what is considered normal for LT cable temperature if ambient temperature is 42 degrees Celsius?
It depends on the type of the cable, by the way, sir. I mean, what is the type of the cable you're going to use? However, by looking into the typical temperatures on the types of cable, again, it can vary from manufacturer. For example, for XLP cable, the normal operating temperature, what is written in usually in the cables are 90 degrees. The maximum allowed temperature during thermography is 130 to 150. So it depends on the type of the cables, depends on the normal operating and the maximum allowable operating temperatures. But for a nutshell answer, it will be, I will say, about 130 to 150. You should be really worried about. But for example, a polyethylene cable, you should be even looking closely at 100 to 110 degrees as well.
Prefuse is asking, considering report generation, is there any specific guidelines which is one should consider and one should not consider?
Well,
Piotr,
yeah,
will
there's
Mhm.
the example of the report in the standard IS 16168. I have shown this on the picture, but maybe, I just embedded this in my PowerPoint. In case you want to see it in details, go to the website of BIS, so Bureau of Indian Standard, and then you can download the standard free of charge. So then you will see what is the table, what are the requirements there.
Okay. So temperature is something that is quite constantly asking, how can we measure temperature when it is thermal box is covered by a motor? So this
Look,
is
all the cameras at what Piotr was mentioning, every camera today senses what is a ambient temperature, and we are able to capture the temperature on the surface of the object what we are measuring as well, and we are able to adjust these two temperatures while we do the thermography. So when we show a live demonstration to the customers who are in request of this, it will be much more clearer than a webinar. It's very simple in that way. It's a very simple setting in the camera.
so Manikandan, you've been asking in the chat box and also question about solar PV. I would request Shyam to talk to you in person since you're asking about power plant. So the standards on IS and IEC.
I will just mention the name alone, the number alone of the standard, sir. I'll take the question from the customer later on. The number of the standard, though we have conducted a webinar as well a couple of weeks before, the standard number is 62446 dash, and it goes on. You can take a 62446 as a reference. Dash 3 2022 will talk about outdoor thermography, but if you take a reference of from 62446, you will have almost all the inspection related to thermal power plants. The video is also available in Mr. Dominic's channel in YouTube. I was able to notice that the recorded webinar is still available in YouTube.
Yeah, but
Thank you.
still, the IEC 62446, it does not determine particular values of the temperature.
Yeah.
It just say compare one component with the other similar ones, or look at the manufacturer specs. So there's no clear ranges of temperatures. It all depends on the conditions, on other components, on manufacturer specs of particular components. So yeah, that's what we can find in the standard.
Great. And another question, Piyush is asking, no, Manjunath Rao is asking, is it mandatory to conduct thermal imaging as per statutory requirement? If it is if it is yes, can you tell us?
To my knowledge, there is no statutory requirement to conduct a thermal imaging. In India, we've practiced these two methodologies as predictive maintenance and preventive maintenance. There is no statutory requirements that a customer has demanded to do a thermal imaging. From the statutory requirement point of view, the standards what I have mentioned to you before, 60364, 62446-1, these are the statutory requirements. If you take Indian standard, 732 NEC 2023 3043 18732 will be the standards which will be falling as a statutory requirement. Again, the statutory requirement can further be looked into from the regional perspective. For example, I'm sitting in Chennai. The safety inspector, though there is a national guideline, there will be a clear instruction from each and every safety electrical inspector that, okay, I'm going to specify on this because my regional condition demands this.
So,
I just want to say one more thing here about the inspection, as we have different electrical inspection defined in, for example, National Electrical Code. But many of them require to maybe turn off our system for some time. Thermal imaging gives you this advantage that you don't need to turn off your system. So once it is operating, once the factory are running, while the customers receive energy from the power utility, you can still do a check with thermal imaging. And later, if you find any anomaly, then during the maintenance, or if it looks like an emergency, then earlier, we can perform more detailed electrical inspections with dedicated meters, for example, for insulation, with micrometers, well, whatever we need.
good. The last question to you, Peter. Is standard deviation mandatory as per my thermal reports for electrical application? The IS standard, it says, we should clarify, IS standard deviation mandatory as part of the reports for electrical application.
Well, yeah, as Shyam said before, well, it is not like the mandatory thing, but it can be really helpful. Plus, again, we don't need to turn off our system and stop production, just make angry several of power users and so on. And anyway, when we stop the production either of the energy, or if we stop production in a factory, then when we are not producing, we are not making money. So here with infrared imaging, we can just, work as normal and still perform the study to check if everything is fine.
So, well, I think Gangadhar Panda, who wants to, you're unmuted. Gangadhar, you can speak to Peter and Shyam. Gangadhar, can you hear me? Okay, I'll just remove probably by mistake. Yeah, unmuted. GK Rajan, you would like to talk? Okay. So,
I think we already exceeded 12 minutes of the time from the audience.
Yeah.
If you can put up your contact details on the last screen, Shyam, if you can. So just before he puts up the screen about Shyam's contact details, I wanted to tell you tomorrow we have a very interesting webinar coming up. I know I'm taking with permission of Shyam. This is something very educational webinar we're talking about. How do we control smoke? Smoke management in lobby, which is atrium, and also basement. Tomorrow at 11 a.m. And very, very prominent figures. That is V. Suresh, who is the chairman of National Building Code of India. He'll be joining, and Sandeep, who is also member of National Building Code and has been there since 2005, 2016, and upcoming standard and 2025 will be joining. Please do join. And this is a very interesting subject that we are talking for. First time we are talking about smoke management in basement and atrium. So, Shyam, would you like to share your screen? You would like to put up your card or something on the screen so that people can write down your mobile number or any number that you would
Yeah,
like.
I put my contact details in the chat box already. I will
Okay.
share my number again. The mail IDs are continuously shared from your team, and I'm also sharing my contact details. Sorry, it's only 9 numbers. Huh? 1 second.
So, nevertheless, we will be writing to all of you, and those who could not join will share the video. And I wish all the very best for Sonel International. Piotr Pawlik was, I don't know what's the time in Poland now. What's the time?
It's about 1 p.m. So still plenty of day ahead of me.
Yes, I think they have lunch at 12, so we are holding him having lunch. So it's a wonderful session today, and always it's pleasure to see Peter talking to us. and educating, creating awareness. And we are so proud to be associated with Sonel in bringing various subjects. And soon, we will announce the next subject, which again brings now knowledge. I want to thank the managing director, the young, dashing managing director of Sonel India, Shyam, for sparing your valuable time and taking up questions and moderating the whole session. I want to thank Shyam for joining. Wish you all the very best. To all those people who have listened to us today, have a wonderful week and stay safe. Look forward to see you again. Thank you so much. God bless you all. Bye.
Thank you very much.
Thank you.